Hello everyone and welcome back to the channel. If you have ever struggled with projectile motion problems, then remember you're not alone. Those big scary formulas for range and maximum height, they are actually limiting you. These are the formulas I am talking about. And in this video, I'm going to show you one concept that lets you solve every projectile problem, whether a ball is thrown from a cliff or to a simple toss. What's the secret? The secret is this. Stop thinking about the arc as a single shape and stop thinking about this as the entire motion. And instead, start thinking about it two separate simple components like this: x direction and y direction. A projectile's motion is actually two motions happening at the same time: the horizontal motion along the x axis and the vertical motion along the y axis. And here is the best part: these two motions do not interfere with each other at all. Let's look at the x direction motion. What are the forces acting on an object in the horizontal direction? We know that no force acts in the horizontal direction. We ignore a resistance. And therefore, the acceleration in the horizontal direction ax is equal to 0. And that would imply the horizontal velocity, initial as well as final, would remain the same. So, the horizontal velocity remains constant. And that would further imply that you could use the simple equation distance is equal to velocity into time to find out the distance covered in the horizontal direction. Of course, do keep in mind that this ux is equal to, let me write over here, ux is equal to u cos theta, where theta is the angle of projection. Now for the y direction, the vertical motion. This is governed entirely by gravity. And the vertical acceleration, you know, is acceleration due to gravity, g. And since we have constant acceleration in this case, we can use the three basic Swatt equations as shown over here. Of course, you could add the suffix y everywhere, wherever you need. And remember that uy is equal to u sine theta. So, this is how we handle the motion along the x-axis and the y-axis. The question is, why is this method superior? Or why is this method better? The reason is because the big range and height formulas that we saw earlier only work when the projectile starts and ends at the same height. That means if this is the ground and an object starts its projectile motion and it comes back to the same level, in that case we can use those range and height formulas. For motions where the projectile path is not complete like this, for example, stone thrown from a height into a sea or an object thrown to a height like this, these big range and height formulas, they don't work. What works is the method that I have shown. So let's summarize. For any projectile motion, first know the initial velocities ux and uy. Then treat the x and y motion independently. For x motion, remember ax equal to 0 and therefore s is equal to simply u into t. For y motion, we know acceleration due to gravity is the acceleration plus or minus g, and then employ the Swatt equations along the y-axis. And you will be able to solve any questions on projectile motion. And of course, remember that time t for both x and y direction is the same. So, with this, you will be able to solve any question. If you want to find out the final velocity, you could use this equation to find out the final velocity, and the final angle that the projectile makes could be found out using this formula. Hope you like this video, and do comment upon this video and tell me what else I can do to help you try out this method, and let me know in the comments. And of course, don't forget to like and subscribe this video. For more videos on projectile motion, please use this link. I'll also paste this link in the description and would like to hear from all of you. Thank you.